In the last class, I discussed about equilibrium of forces. In this module, concept of equilibrium, conditions of equilibrium, Lami's theorem, free body diagram, problems on one sphere, problems on two sphere, problems on three sphere, and also the strings are mentioned. So we know that a body is said to be in equilibrium provided it remains at rest, if initially at rest, or at constant velocity if initially it was moving. And also conditions of equilibrium for concurrent force system are summation of fx is equal to 0, summation of fy is equal to 0. And for the non-concurrent force system, summation of fx 0, fy 0 and m is equal to 0. The Lami's theorem says that if a body is in equilibrium under the action of three forces, then each force is proportional to sine of the angle between the other two forces. I have discussed this Lami's theorem. And also there are some limitations of Lami's theorem. So this theorem, it is applicable only where there are three forces. Okay? If the forces are more than three, we have to use equations of equilibrium. And Lami's theorem, it is applicable for coplanar forces, that is forces acting on the same plane, and concurrent forces, forces acting on the same point. And here now we will discuss the problems on one sphere in this video. First problem is a cylinder of weight 600 Newton rests on the surface and it is as shown in the figure. Determine the reactions at the contact points. The contact surfaces are perpendicular to each other. This is a cylinder given and the cylinder weight is given. Weight always acts downwards. It is 600 Newton. And it is the cylinder, it is the contact point, one contact point is A and other contact point is B. It is in contact with 2 points, one is A and other one is B. So and here it is a given angle is 30 degree, here it is 60 degree. So while writing this free body diagram of the sphere, what we have to do is, so when I remove this contact surface, I'll write one reaction here. And that reaction is normal to this roller. Okay. And also when I remove this one, I'll write another reaction that is also normal to the roller. So since this is a point here, here you can see here, I'll write the reaction as RA. So it is a normal means 90 degree. This angle is 90 degree. This angle is 30. They have given. So always we want an angle with respect to the horizontal. This is a reaction and always we want an angle with respect to this. Okay, this line or horizontal line. This is a 90 degree. This is a 30 degree. So this angle must be 60. And also similarly here, this is when I remove this contact surface, I'll write one reaction. That reaction is RB. Okay, and here the angle is given as 60. Here it is 90. So angle with respect to this reaction is, that is with respect to this horizontal axis of the reaction is 30 degree. This is 60, this is 90, this should be 30. And also we will shift this force, that is RA force, from one point to the other on the same line of actions according to the principle of transmissibility of forces. And also I'll shift this RB to in this direction according to the principle of transmissibility of forces. You can observe here. So this diagram you can observe, we have shifted the RA and RB forces and we have written the angle with respect to this with respect to the horizontal axis. That is RB, it is inclined with respect to 30 degree and RA, it is with respect to 60 degree. You can observe here RA is with respect to inclined with respect to 60 degree and RB with respect to 30 degree. And the weight acting is always, we will show the weight downwards. That is 600 Newton. Now we will apply the Lami's theorem. That is, I'll take the first force RA divided by sine of the angle between the other two forces. Other two forces are RB and 600 Newton. So sine of the angle between the other two forces. This is a 30 degree. This is 90. 90 plus 30. Sine of 120. RA divided by sine of 120. That is equal to RB divided by sine of the other angle between the other two forces is, for RB, other two forces are RA and 600 Newton. The angle between these two forces 90 plus 60, that is RB divided by sine 150, that is equal to 600 divided by sine of the angle between the other two forces. Other two forces are RB and RA. So here it is 60 and here it is 30, so it is sine 90. So RA is equal to 600 divided by sine 90 into sine 120, or RA is equal to, we'll get this value, that is 519.62 Newton. Similarly, RB, you equate RB to RB divided by sine 50 is equal to 600 divided by sine 90. Sine 90 is 1. Your RB is 600 into sine 50. 600 into sine 50 is 300 Newton. This is how we will solve one sphere problems on equilibrium. Let me take another example. So in this example, you have to determine the tension in the string and the reaction at the contact surface for the cylinder. This is a cylinder, tension in the string. This is a string. So tension means always we will write the arrow, it is away from this point, away from joint, away from these points. Okay, this is connected to a string. String means the tension. We will write the arrows away from the point. Okay, for the cylinder of weight of the cylinder is 1000 Newton and it is as shown in the figure. So I have written a separate figure here. So when I remove this one, when I remove this contact surface, we will get one reaction. That reaction you can take it as you can name it as an RA or you can name it as an VA. That doesn't matter. If I name it as an RA, that is normal to your sphere. Okay, 90 degree. So this angle they have given 60. Always we want an angle with respect to this reaction. That is 30 degree. If this is 90, this is 60. This will be 30. And similarly, we need an angle of this one string also. Okay, that is with respect to the horizontal axis. What is the angle? If this is 60 degree. This total angle is also 60. Here we are having a 15 degree. The remaining angle will be 45. Okay, you can see here. And have written separately. These forces are taken away according to we are shifting the forces according to the principle of transmissibility of forces, and I have written the last diagram here. You can see the last diagram. So that there is a tension force, it is inclined with respect to 45 degree. That a reaction, you can see here with respect to the horizontal it is 30. Okay, just I shift this reaction to here. The same angle with respect to the horizontal it is 30 and the weight is 1000 Newton. Weight of the cylinder. Just I am applying the Lamis theorem here. Using Lamis theorem, T divided by sine of the angle between the other two forces is 90 plus 30, that is sine of 120, that is equal to, here you just make it as an R. This is R divided by sine of angle between the other two forces, that is 90 plus 45, it is 135. You please make it as an R here. This is R divided by sine 135, that is equal to 1000 divided by sine of, this is 45 plus 60, it is 105. Just you equate this one. T divided by sine 120 is equal to 1000 divided by sine 105. You will get this answer. And R, this is an R. R divided by sine 135 is equal to 1000 divided by sine 105. You will get the value of R. Okay, there is tension in the string and also the reaction at the surface. This is the next problem. It is similar to the previous one. So find the tension in the string and the reaction at the contact surface for the cylinder of weight 1000 Newton placed as shown in the figure. Here just an angle it is different. Okay, this angle in the question they have given this angle 50 degree and 20 degree. So I have written in the dotted lines the other angles that I have written. Okay, just for the clarification I have written the this other two angles, that is 30 and 40 I have written, but in the question the angle given are 50 and 20. So you can see here just when I remove this contact surface I will write one reaction. That reaction is normal to the roller. So this is 50 degree, this is 90 degree, the remaining angle should be 40, and you will shift this, transfer this according to the principle of transmissibility of forces. You will get one reaction there, and inclination with respect to that it is 40. Okay, here total angle is 50, here the angle given is 20, the remaining angle will be 30. So the separate free body diagram it is written here. This is since it is a string T I have taken away from this joint, and the angle inclination is 30 degree, and the reaction, the inclination is 40 degree. Total weight acting is 1000 Newton. You can see here This tension, this is you can name here T. So if this is 30, this is also 30 because it has an alternate angles. Angle with respect to the horizontal is 30, and reaction angle is with respect to the horizontal is 40, and the total weight is 1000 Newton. Just we will use Lamb's theorem. Since there are only three forces, we can use Lamb's theorem. That is R divided by sine of, that is 90 plus 30, that is equal to T divided by sine of 90 plus 40, and that is equal to 1000 divided by sine of this one 60 plus 50. Okay, 60 plus remaining angle here is 60 plus 50. Okay, just I'll equate this one. R divided by sine 120 is equal to 1000 divided by sine 110. You'll get this R. And T divided by sine 130 is equal to 1000 divided by sine 110. You'll get the value of T. The last problem. So this last problem is similar to the previous one. So you determine the reactions at the point of contact for the sphere. So point of contacts are A and B. Just they have changed the angle here. It is 30 and here it is 45. Total weight is, or weight of the sphere is 1 kilonewton. So you can see here we have written a free body diagram of this one. This is whenever you remove that contact surface, you will get reaction. One reaction, that reaction is RA, that is always normal to the roller. If it is 90, this is 30, this angle will be 60. You can see here RA it is inclined with respect to 60, and we have shifted from according to the principle of transmissibility, that is RA here to here, that is 60. And similarly, when I remove this contact surface, you'll get one reaction. That reaction is again normal to your roller. If this is 45, this is 90, this angle will be 45. And according to the transmissibility forces, we have shifted here, and this angle is 45. And the total weight is 1 kilonewton. Just use Lamb's theorem. That is RA divided by sine of the angle between the other two forces, that is 90 plus 45 is 135. RB divided by sine of 90 plus 60, it is 150. 1 divided by this one is sine of 45 plus 30, it is 75. Thus you equate this, you will get the value of RA and RB. So this type of problems you will get on one sphere. And normally this one sphere problems, it can be solved easily by using this Lamb's theorem. Next is problems on strings. So figure shows a system of cables in the equilibrium condition under two vertical loads. Okay, loads are given. One is 300 Newton, other one is 500 Newton. You have to determine the forces developed in the different segments. Segments or a member means if I consider this joint B. So B is connected to the point D, A and C. So the members in the this point B are BC, BD and BA. Similarly, if I consider the joint C, the members in this joint are CE and CB, and also 500 Newton is acting downwards. So we have to write the free body diagrams at the point B and C. So and it is as shown in the figure. You can see here, since it is a string, the tension, this tension, it was when you are writing an arrow, it should be always away from your joint. This is a B joint. So this B joint, we are writing BD segment means, or a BD member means, we always write an arrow away from the joint. So tension in the string BD, I'll take it as a TBD. This I'll take it as a TBA, and this one is TBC, and the other one is 300 Newton. You can observe here. So this is a joint B, and the tension in the string BD we will written as TBD. TBD means tension in the string BD. So from the point, so whenever if it is a tension, always you have to write an arrow away from the joint. That is TBD. So inclination is 45 degree, and other one is TBC. So it is connected by a weight 300 Newton, and also other member is TAB. And this joint, so I'll write this also, the free body diagram of this joint, that is TCE, TCB, and other one is 500 Newton. You can observe here. So first we can take this TCE, TBC and 500 Newton. First we will consider this one, because here we are having only three forces. Here we can use the Lamb's theorem. Okay, from the free body diagram at the joint C. We are using Lamb's theorem here. That is TBC, this is a TBC divided by sine of 90 plus 60. That is equal to TCE divided by sine of 90 plus 30, and 500 divided by sine of 60 plus 30. Can observe here. TBC divided by sin 150, TC that is equal to TCE divided by sin 120, that is equal to 500 divided by sin 90. You will get the values of TBC and TCE. Just you equate this one. TBC divided by sin 150 is equal to 500 divided by sin 90. You will get the value of TBC. TCE divided by sin 120, that is equal to 500 divided by sin 90. You will get the value of TCE. So we are knowing the values, or we are knowing the member forces at the point TBC and TCE, that is tension in the string BC and CE. In these segments we are knowing. Next we will consider this free body diagram, that is at the point B. Okay, you can observe here we are having four forces, that is TBD, TBC and 300 Newton, and other one is TAB. Here we can't use Lam's theorem here. Since there are more than three forces, we can't use Lam's theorem. We will go by equations of equilibrium. This will take summation of Fi is equal to 0. The summation of Fi is equal to 0, assuming all the forces in the, will take up all the forces in the vertical direction. So this is an inclined force. I'll resolve this one. This is plus TBD sine 45. This one, it is minus TBC sine 30. And this one, it is minus 300. You can observe here equation. So we will sum up all the vertical forces. Okay, vertical forces, since summation of Fi is equal to 0. Here we are knowing the value of TBC. Just I will substitute TBC here in this one. You will get the values of TBD. Okay, tension in the string BD. You will get the value easily because TBD is the only unknown. TBC we have calculated. Okay, just to substitute here, we will get the value of TBD. And similarly, you use another equation, that is summation of Fx is equal to 0, summing up all the forces in the horizontal direction. That is plus TBD cos 45 plus TBC cos 30, and this is minus TAB, that is equal to 0. So here we are knowing the values of TBD and also we are knowing the values of TBC. Thus, if we substitute the values of TBC and TBD, we will get the value of TAB. So TAB is equal to 641.5 Newton. So now we have calculated the member forces or forces developed in the different segments. Okay, that is BD, TBD, TBA, TBC, TCE, and TCB. We have calculated all the forces in the members. Next problem. So compute the tensions in the string AB, BC, CD as shown in the figure. This one you have to compute the tensions in the string AB or BA, the same, BC, and the one is CD. Okay. So now B is connected to the point A and C, and also this joint C is connected to the point D and B. So we will write the free body diagram separately. So first the free body diagram of the B joint we have written. You can observe here from the B joint it is TBA, TBC, and this one is 1000 Newton. Okay. This is TAB or TBA, the same, TBC, and other one is 1000 Newton. You can observe the C joint here. TCD, tension in the string CD, this one TCB, and this one is 800 Newton. So if this is 60 degree, this is also 60 because alternate angles. If this is 30, this is also 30. We are knowing this. And we have written here TCD, it is inclined with respect to 60 degree, TBC 30, and this is 800 Newton. And this value, it is theta, it is given, just write as it is theta. First we will use this one because here we are having the three forces. We can apply Lam's theorem easily at the joint C. So at the joint C, just apply Lam's theorem. This is TPC divided by sine of 60 plus 90. Okay, TCD divided by sine of 90 plus 30. And 800 divided by sine of 30 plus 60. 800 divided by, can observe here, 800 divided by sine of 60 plus 30, it is nothing but 90. So if I equate this, so TBC divided by sine 150, that is equal to TCD divided by sine 120, that is equal to 800 divided by sine 90. So just equate TBC divided by sine 120 is equal to 800 divided by sine 90. You will get this equation. Similarly, you will get TCD. So afterwards, here we have to use the equations of equilibrium because here theta is also the unknown. Okay, we will use equations of equilibrium. First, I will use summation of Fx is equal to 0. Summing up all the forces in the x direction. You can see here, this is minus TAB cos theta. This one is TBC cos 30. TBC cos 30, that is equal to 0. Okay, and then TAB, you rearrange it, TAB cos 30, that is equal to, so this CBC value is known here, just substitute TBC value, that is equal to 400 cos 30. Then I will use summation of Fi is equal to 0. Fi, that is minus TBC sin 30, and this one is plus TAB sin theta, and other forces minus 1000. You can see here. And I'll take this one, TAB sin, just I'll rearrange this one. TAB sin theta is equal to 1000 plus TBC value we are knowing plus 400 sin 30. We will get TAB sin theta is equal to 1200. I'll call this is equation 1. First one, this one, TAB cos theta is equal to 400 cos 30. I'll call that as equation 1. This one, TAB sin theta is equal to 1200. I'll call this as equation 2. So I'll divide equation 2 by 1. So sin by cos is tan, that is equal to 1200 divided by 400 cos 30. Then you'll get theta. Theta is 73.9. Once you'll get theta, so TAB value we will come to know by using any one of this equation. So TAB is equal to 1200 divided by sin of 73.9. We'll get the value of TAB as 1249 Newton. Next one. In the figure, the portion BC is a horizontal. BC of the string is horizontal and this pulley is a frictionless. You have to determine the tension in the different parts of the string. Also, you have to find this one W1 and W2. This is a problem given. Just I'll use this one and I'll write the free body diagram at the point B and C. So because B is connected to A, C and also W1. So since it is a string, always string it will be in a tension. So this is a tensional string BC. It is acting away from this TBC, TBA and W1. And this one at the joint C, it is TCB and this one is W2 and it is connected by a frictionless pulley. Okay. We have written a free body diagram of the points B and C. Okay, this at the point B it is TBC, TAB and W1. The angle is here it is total angle, it is 120 degree. Total angle here it is 120 degree. So this total is 180 we are knowing. So 180 minus 120, this angle will be 60. And at this joint also, at the C joint, it is 135 degree here. Angle is 135. And here total angle, so straight line it is a 180. 180 minus 135 is here this angle is 45. Okay, it is connected to a friction. It is connected to frictionless pulley. So it is 1000 Newton. So we have taken 1000 Newton here. This is 1000 Newton. Okay. So next we will use the Lamis theorem. So you can observe here we are having only three forces. You can apply either Lamis. You can apply Lamis theorem for both point B and C. Okay. Let me apply the Lamis theorem for the joint C first. Okay. Let me start with this joint C. Okay. It is TBC divided by sine of 90 plus 45. That is equal to W2 divided by sine 135. That is equal to 1000 divided by sine 90. Sorry, 100 divided by sine 90 because the weight is 100 divided by sine 90. So if we equate this one, we will get the value of TBC and also we will get the value of W2. Next, we will use the Lamis theorem for the point or joint B, that is TAB divided by sine 90, TBC divided by sine of 90 plus 60, W1 divided by sine 120. You can observe here we will get the values of TAB and W1. So this is how we will solve the problems on string. And this is also another problem. Here we have to calculate this theta, angle theta. Determine the angle theta for the system of strings ABCD is in equilibrium, and it is as shown in the figure. So just we have written the same procedure is same. Here we have written the free body diagram at the point B and point C. At the point B it is TBA, TBC, and 20 Newton force it is acting downwards. Can observe here 20 Newton force acting downwards, TAB, and this one is TBC. Similarly, at the joint C, I have written the free body diagram. This is a TCD, TCB, and this one is 25 Newton. TCD, TBC, and this one is 25 Newton. So here we are having the three forces, but theta is unknown. Just we'll go by using equations of equilibrium. First, we will use summation of fx is equal to 0 at the joint B. Okay, summation of fx is equal to 0 at the joint B. Fx is equal to 0, summing up all the forces in the vertical direction. That is, this one will be, okay, fx is equal to 0. This one will be TBC sine theta, and this one is minus TAB sine 30 is equal to 0. Okay, and this TBC sine theta, that is equal to, I'll write it as TAB sine 30, and I'll call it as an equation 1. Next, I'll use summation of fx is equal to 0 for the joint C. You observe the joint C here. Okay, we will use fx is equal to 0. That is TCD sine 60, that is equal to minus TBC sine theta is equal to 0. So TBC sine theta is equal to TCD sine 60. I'll call this as equation 2. So from equations 1 and 2, we will get TAB sine 30 is equal to TCD sine 60. I'll call this as equation 3. Next, we will apply summation of Fy is equal to 0, summing up all the forces in the vertical direction at the joint B. Okay, vertical direction, that is, this one will be minus TBC cos theta, and this one will be plus TAB cos 30 minus this force, minus 20. Okay, you can observe here. Okay, TAB cos 30 minus TBC cos theta minus 20 is equal to 0. So TBC cos 30 is equal to TAB cos 30 minus 20. So similarly, I'll sum up all the forces in the vertical direction at the joint C. You can observe that TBC cos theta plus TCD cos 60 minus 25 is equal to 0. TBC cos theta is equal to 25 minus TCD cos 60. This is I call this as equation 4. This is equation 5. Okay. Okay, from equations 4 and 5, just I am rearranging this, and I am writing TAB cos theta is equal to 45 minus TCD cos 60. And we will substitute from equation 3 for TCD. Okay, TAB cos theta is equal to 45 minus, we will substitute the TCD value from equation 3. Okay, this is the value of TCD from equation 3 into cos 60. So then we will get the value of the TAB. Afterwards, from equation 1, this TBC sin theta is equal to 38.97 sin 30, and from equation 4, TBC cos theta is equal to 38.97 cos 30 minus 20. You call this is equation 6 and 7. Just you divide equation 6 by 7, sin by cos is tan. Okay, that is equal to, you divide this one, you will get the value of theta. Okay, thank you.